Abhi, I'm excited to talk about creating smart contracts. The next level, we had an overview of it, and this is such an exciting aspect because you hear it name dropped. Of course, Ethereum had its integration and update, and this is something that I think is going to be very important for applications in business, Web 3.0, all of those things.
Yeah, and that's exactly right. I think a lot of people need to understand a lot of people know kind of a smart contract, like the word and stuff like that, but I guess they should know what is actually a smart contract, like what does it look like how can they interact with it, and what should they be looking out for when they're looking at a smart contract, and when they're looking at something that they're interacting with in Web3, because it's important to know, otherwise you're going to get tricked or scammed. You want to make sure you're safe out there, and you want to make sure you understand what you're doing when you're doing stuff. We're using money basically in Web3. A lot of your tokens are monetarily valued, so you want to make sure you're using them and in a correct way, and knowing what's happening with the smart contract calls. So yeah,
and we're going to do a demonstration on kind of a simulation platform.
Yep. So let's we can go ahead and do that. So I've got a sample smart contract popped up here on the screen. This is something that's very boilerplate. And the reason why I wanted to show you a boilerplate token is because it was smart contract, because it's easy to tell. This is what you'll commonly find in a smart contract in an ERC20. So ERC20s are tokens. This can be an ERC 721. That would be an NFT. An 1155, which is also an NFT. It's a different kind of NFT smart contract. But as you can see, this is an ERC20, and this is coming from, a lot of this code is going to be coming from Open Zeppelin, and this is all viewable to everyone. And this is importable code. And what we're doing here is we're, overriding a lot of the functions on here, and then we're kind of modifying them a little bit and calling them here. So if you're calling them internally here, if you're wondering what just this code is right here, but I'm not here to explain code, in depth. I'm here to sort of show you what's happening and what exactly smart contract is. So a smart contract is basically a collection of these functions, right? As you can see here, there's a function here to mint. So as we know, minting tokens is to create new tokens. So we can call the mint function, and we can mint new tokens. We can pause a contract, or you can unpause a contract. And as you can see, only the owner can do that. This is how it's going to look for an ERC20 smart contract. For now, I'll show you how this is working and how to deploy it, and just create a mini token, right? So we can create one token. It's called, right now we can name it my token. We'll name it what do you want to name it?
The Christmas token.
Sure. Christmas token. And we'll just do CTK or something. What's happening here is when we're going to start up this contract, we're going to basically call it with these variables, and we're going to call it with an initial supply. So we'll just have an initial supply right here of say we could do 1, 2, 3, 4, 5, 6, just a supply like that, and we'll just add a few more zeros on there so we actually have more supply. And what's going to happen is we can either deploy this on a VM, which is a virtual machine, or we can do it actually on chain. And I'll do a deployment on chain here, and so everyone will be able to see this token. So anyone watching this will be able to go look at the token on live, and they'll be it will not to buy it. You can't buy this token. I will not, but you can look at it, and if possible, you can get some token. I don't really know how you would only get it from this contract. And so basically we'll take a look at how to actually use these functions and stuff. So let's deploy, and I've deployed here. I'm deploying it to a VM here, and just to show you kind of what the test would look like. So you can see that the owner here would be this address that I'm using right here, which ends in EDDC4. And over here, this address owns this contract. You can see what the balance of this contract would be. So right here, this is the balance of function. And we can click on this and you can see that their balance is, this much. This might actually be from the other deployment, but yeah. So yeah, this would be the balance of this address for this token. And you could over here, you can transfer. There's a transfer function and this transfer function. I wish I could show you here, but I guess I could show you in Open Zeppelin.
The word is smart contract, but I kind of call it an automated dumb contract, because it's not, it doesn't have any intrinsic intelligence. It's just code, like a recipe run.
Exactly. And that's kind of what I wanted to show as well in this, that it is just code. So we can see right here, from what the events are right here, there's a transfer event here, and this transfer event, let me actually transfer. So this transfer event takes in a two address and an amount. And over here, we can actually see right here, it takes in a 2 address and an amount. You won't be able to see that in this code here. And the reason why you won't see a transfer function in this code is because it's actually being imported from Open Zeppelin on deployment. So this code right here is being implemented into this contract. And you could see it a little bit better if I were to sort of create another contract right here. I could just do test contract 2.sol, and sol stands for solidity. So it's a file extension for that. So smart contracts always start with, declaring which compiler version it is. And you can do like 0.8.4 or 0.8.5 like this. And you can, basically you can declare a smart contract just like this. Contract, my token is, and these are like add-ons that you can put on, but you just have to do contract my token or something like contract something. Like you can type in whatever you want here and it would work. From here, you can basically, let's just have this copied over so that we can, so we can delete all this and we could start from like a scratch contract here. And we can name this test contract. And we don't need this. So this uint wouldn't matter. And from here, this is basically how the smart contract looks in its skeleton. You don't even need
the backbone of it.
Right. Yeah. You don't really even need those, but you could add those. And you can have a function over here that would be like hello world or something like that.
Right.
And from here, you would be able to, create like some sort of variable. And then from there, you'd be able to add it in and whatnot. So basically what I'm saying is just like how these functions are over here. And you can, in the pause function, or if you wanted to create another function over here, you can go like this. So you can go like, we'll do the hello world over here since I've already have this deployed, so that we don't have to go through anything else. So here we can have some sort of, you can declare some sort of uint and then have that like labeled as like start amount or something, start amount equals, and we could just have that at like 0. Right. So this is a view only function at this point. So we'll just keep that like that. We will, let's see, what do I want to do here with this smart contract? I haven't really thought about like what exactly I want to do with the smart contract.
I got it. Well, this is what's fun about it is we're just showing it, creating it. Could you pause a moment and kind of talk about the compiler, the language, and the Zeppelin? Okay. What are they?
Yep, sure. So Solidity compiler is basically it's the EVM version, EVM compiler version, and what it's going to do is it's going to take all this code. It's going to take it into a binary, an application binary interface. Within that application binary interface, it will have it so that each of these functions are listed out, and you'll be able to see the ABI when actually I compile and send this to the actual blockchain. And when we are able to do that, we'll be able to see kind of what what we need for the functions to basically the UI needs these functions essentially, right? So it needs to be able to know that there's an unpause and a pause function on the UI. The reason why the ERC20 is the name, right? It's named ERC20 or ERC20 burnable. Yeah. These token standards are there because the UI needs to have these kind of functions already within them. So in a wallet, right? In your blockchain wallet, like Trust Wallet or something like that, there would be a transfer method on there that would say, okay, so there on the smart contract, there is a transfer method. And we can call this transfer method on the smart contract to transfer from one place to another. If this transfer method is not within, an ERC20, it would not know how to transfer it or whatnot, right? So I'm trying to think of a better way, a good way to explain.
Let me try something on it. First of all, the concept of a compiler versus an interpreter, which is like in the early days of computing, it ran on the fly, is you're working in something that's also doing a little monitoring to make sure you don't make too many mistakes, usually. And it's kind of like grammar checker, but in the programming world. And then it's often going to convert it into the core system that runs on the blockchain. So this could be a possibly more robust language that then is converted to something native to it. And in the early days, they might have a compiler that would convert it down to what was called machine language, where it's the absolute primitive, but we aren't doing that here. So this is more like an overview tool for development, and often it'll let you do a simulation before you load it onto the computer. Is that, are we on course with that?
No, you're right. Yeah. So essentially, I mean, the way that you're saying it is like, yes, this does. So the compiler does actually bring this down into a binary machine code. So right now we're coding in Solidity. We can use this thing called Viper, which is another language that's used for coding Ethereum smart contracts. And all these languages kind of compile down to the same thing, to the EVM. So the EVM sees the same thing. It'll, no matter which language you're using, it'll compile down to the whatever it needs to know. Essentially, what's being stored on the blockchain and the ABI and whatnot. What I was talking about there was more for the UI side. So yeah, I guess your way was a little bit better. Your way of explaining that was actually, the right way to explain that. So yeah.
Well, your job is to be the programmer. Mine is to help.
Clarify
it. Okay, we're a team. On the Ethereum, because we're talking about, in this case, the Ethereum blockchain.
Yes.
On the Ethereum blockchain, what is the name of its native code that it has there? So
I mean, in Ethereum we use Solidity or Viper, or like there's some other offshoots of whatever these are, but people made these languages to connect and talk to the EVM, or the Ethereum virtual machine. The Ethereum virtual machine takes all this code in, and then it will basically, there's these things called opcodes, as I've explained. Basically, opcodes the code will compile down to these opcodes, and it'll be like, okay, there's an add opcode or a subtract opcode, and then these will then be translated into gas. Like it'll calculate the gas amount, it'll do all these operations, and then it will give you the result plus the gas and stuff like that. So to answer your question, it's basically the native Ethereum language would be anything that talks to EVM, but most popular it would be Solidity, which is Sol.
And just to define EVM, define that for people.
So EVM is the Ethereum virtual machine. For people who don't really wouldn't really understand that, it would be like where Bitcoin has its ledger, it's block by block transactions, right? So each block in the Bitcoin ledger would have like transactions like to from, sort of, right? In Ethereum, these transactions would be held inside of this, what is known as the world state. The world state, the EVM world state, would be like a whole tree of user accounts, and then what the transactions are on them are all there. what the EVM does is essentially its sole job is to mutate the world state. So from going from this world state to the next world state, what happened between this world state and that world state, and just changing a user value. So like on that tree, if say I sent Ethereum to you, on that tree, it would be like, okay, so, I sent this, it would deduct basically Ethereum from my account, and then it would, put it on, it would add it onto your account. And this would be verifiable via transaction and then a Merkle proof and stuff like that, that the validators can check. But the EVM essentially does the calculations for all that. And what's the previous state and the new state.
And then it updates it on the blockchain. So it's like does the calculation and it gets updated. And the other thing that I want to add to this is we think of processing on an individual computer, and instead of an individual computer, this multiple systems working on it. It's kind of like and I'm going to try an analogy. It's like you have a quad core, so there are multiple processors working. Well, imagine if that was separated out across the world instead of not in a computer.
Right. Exactly. Yeah. You're exactly right. It's a world computer, essentially, Ethereum. Yeah. So, and that's basically what I was like. Yeah. So when I was saying where it's changing the world state, it's only able to change that world state is if the world of computers that are controlling Ethereum accept that into, validate it and accept it into the blockchain. No one can just propose a new world state and then just have that as the world state that as truth, right? Truth can only be kind of created if there's a consensus amongst the computers that are around the world, basically the Ethereum network, right? So that's essentially the EVM is what that is. Like people around the world who are doing these validations and it are basically running mini virtual machines within their validators, and that's known as the EVM. And the EVM is actually a small portion of the validation validator program that is set in with them. So,
and one thing I want to add that's so exciting is on the computer, the program would be running, but it might be updating in the same spot. When in this case, we're doing updates that are being generated into new blocks because it's as we go along.
Right. Yeah. It's essentially just updating think of it as like a database. The world state is the database, and it's just updating that database over and over again. Whereas, all these validators have access to this world state to see, what it's looking like how it looks. Not, some validators will be like half validators. Some will be full validators where they download the entirety of the world state history. Some will just have the recent past 10, I think it's what they do. Past 10 world states, and then and past 10 blocks, and able to kind of go off of that for validation. So yeah,
excellent. I know that was a tangent, but that was
that's
very exciting to work with you on it. And then we have the Open Zeppelin.
Yeah,
and it sounds like it handles a lot of the workload for you. So it's sort of
right.
Am I right in saying it's sort of like having apps or subroutines?
Right. So why we use Open Zeppelin in smart contracts is essentially, if you think about what smart contracts are, they're essentially, a lot of them are going to be dealing with monetary tokens, right? That have monetary value. And you don't want to really misappropriate any code, have code that you don't want to have that sort of security flaws in your code, right? Especially when you're dealing with other people's money. What Open Zeppelin does is it allows for a standard to come in, and it allows for a developer basically to say, okay, I want to import the ERC20 contract from Open Zeppelin, right? And this way, I don't have to create my own ERC20. I don't have to code it all up and have it precisely as it is, so that I can go out and do testing and auditing or whatever. I can already have an audited piece of code in my code base that's already been tested by millions of devs and stuff like that, so that I can not only can I reduce development time, I can reduce development cost and increase security exponentially in my code, right? Because it's much better to go to someone else's code and use theirs than write your own, right? If I were to make my own function here and override some of these other functions or whatnot, that could, you know, insert some variability into it. But the thing is, like, I would have to know basically what kind of characters, like, you know, do I want a uint 256? Like, is it properly gas optimized? Is it properly secured? Like, you know, stuff like that, right? You don't want it to be not secure. And what I mean by gas optimized is like, do I have the proper amount of data allocated for this variable? Like, is this variable going to be above a 256 at any point? Because if it is, with Solidity past, like, I think 0. There's a compiler update where if it is above this 256, it would actually just reset back to 0. So if I were to have like a huge number that would take even more than a 256, you know, would have, right, then it would actually, the value would be 0. And that's not tested code. That's unsecure code. That can be code that I wrote that shouldn't be there. And that kind of, you know, that kind of issue could make it so a hacker can see this and be like, wait, if I just do something, if I can manipulate this value, and if right now this is like, you can't really manipulate this, but if the hacker was able to do this, then they could just reset it back to 0, and then the smart contract would be compromised, right? And at that point, there's nothing you could really do.
Well, I think this is two things I want to say. One, this is where the value of someone like you reviewing code is going, okay, it looks like they followed good procedures here with tested in the community. That's why this is such a new concept, the open source. We think of controlled inside a company. No, we've got a world of programmers that have been working on this, potentially making it more bulletproof than a group of people sitting in an office paid by a regular hourly check. And I think this is another paradigm that's existed in the open source that people don't realize how brilliant that is.
Yeah, I agree. I mean, I think that like everyone wants, like, all the developer community in Ethereum. This is the reason why actually Ethereum, you see a lot of these other layer ones, like, you know, you see Solana, you see you see Cardano, because Cardano uses Plutus, which is what their language is.
Yeah.
The Ethereum developer community, like this, right? Like, this is just super useful. This is the reason why Ethereum development is so much higher than the others, as well as, you know, of course, Ethereum has tenure over all these other layer ones. But the reason why you see a lot of projects on Ethereum, Polygon, and all these Ethereum based layer ones is because of something like this, where they're able to have code readily available that's already, you know, audited, it's already vetted, it's already gas optimized, right? Like stuff like that. And, you know, back to like what I was saying over here, where yes, there's a vulnerability here. There can also be a vulnerability where, like, do I really ever need like, if you're looking at like category IDs, and the ID can only really ever reach like, you know, 20, like there's only 20 items on your menu or whatever like that, right? And there's only ever 20 items on your menu. You don't ever need like a uint 256. You can, you know, do something even smaller. You could do, you don't see that that could also cause gas issues, right? Because your customer, your end user is paying more gas because you've allocated more memory for something that you don't really need more memory for. Whereas if you're using Open Zeppelin code, you're using, you know, open source code that's literally like it's you know, properly gas optimized, vulnerability checked. There isn't many things that can go wrong there unless you try to modify it, stuff like that. That's the reason why a lot of people like to use Open Zeppelin code. That, you know, have pausable, ownable, you know, extensions like burnable, and, you know, ERC20, like stuff like this, like just add-ons to your code, making it more secure and making it more available to developers and developer friendly. And therefore leads to more development within that ecosystem. And that's what you were saying, like with the open source model that a lot of web developers have been going into. It's like, you know, having this huge collaboration between developers makes development way faster. And you can see the kind of the boom of cryptocurrencies over the past few years because due to this kind of stuff where people are like, okay, so, you know, this, I can have a starting point right here. You know, I could do this, I could do that. I've created NFTs where like, we had a starting point from the ERC 721. And then we've taken it a little bit further where it's like, okay, well, we want some sort of lottery system within the NFTs where each NFT can have a specific category, and that category can only be one of 4 numbers and stuff like that, where you're getting a random number and then you're generating it, stuff like that. That code, that code needs to be audited, the randomized number, and secured and gas optimized. Whereas, if I were to create my own NFT project, like I would need to make sure it has, I would make sure it needs to have like all the functions that this code already has, and it's already written for me. So why would I use why would I use my own code there, right?
And why I think this is so important is we see how software is developed from main companies, not to mention them, but and it seems like, my gosh, now they upgraded it and I need a bigger processor. Well, it's not necessarily better code. It might just be they slapped stuff on top of something else and they didn't go for optimum functionality. And the open source community, in my experience, generally is going for more elegant, more efficiency, things that we'd like our companies to do, but on a time crunch in those, they often don't happen.
Yeah, and there's usually proposals each time that like there's new proposals, right? Every each time, even now, like this ERC 721, ERC 1155. Basically ERC, what it stands for is Ethereum Request for Change, right? Yeah. So there's basically proposals. There's also EIP. I think you've probably heard of EIPs. EIPs are, Ethereum proposals, right? Ethereum implementation proposals. And what these are new standards coming into the Ethereum development cycle, and people can criticize even ERC 20 that's already been used for years now. People can modify this and make it better. Like there's people who are making ERC 20s now that can be modified. So before, when a smart contract, was in play, it was not able to be modified. Now there's modifiable or upgradable smart contracts. Mm-hmm. Sorry. So now you can upgrade on top of whatever. So if there was something that you ever needed to change in a smart contract in the future, if you have a token, you're kind of already just screwed there, because you're just, okay, now it's just a token that's already there. Whereas now with the newer smart contracts, you're going to be like, okay, well, now I could just implement like an update and then have a new token, have a new upgrade on top of the existing token instead of making a new token altogether, right?
Yeah.
So it makes it a lot cleaner. A lot of people can criticize that because it doesn't really go with the fact that immutable code, like, smart contracts are supposed to be immutable, nothing's supposed to be changing. So there's, good and bad to both sides. There's a lot of changes going on within the community altogether, like in the development community all the time. So yeah, as you were saying, like if you put out code there, if you put out code into the world and people look at the code, and then they will criticize it on the internet, as we know, when you put something out on the internet, everyone will have something to say about it. And a lot of the times, like, you'll find someone who's, better, who has a better solution to something than you do. So, at that point you can improvise and restructure the code to where it's more, user friendly and better altogether in terms of for the development community. And then that would be implemented in like an Open Zeppelin version, like a new version. So you can even see right here, there's other versions. Right now we're on 4.4.x of these contracts, right? So there's newer versions coming out, and these are for, upgraded versions of the compiler. The compiler for Solidity is also ever changing. So, as I was saying before, there's a vulnerability where this resets back to 0. Mm-hmm. This has been fixed, I believe, in a newer Solidity patch. Some people who know the compiler versions exactly by heart would be able to page in here. But yeah, they fixed this, and they made it so that if you wanted to have that 0 override functionality, there's actually like a way you can do that. I don't know off the top of my head. I would have to look it up. But yeah, I mean, there's a way to do that now, and I know that. But that's not really a common thing that you'd run across. But it's something that shouldn't be overlooked, especially if you're making production ready code using people's money, right? So right now, when we're just playing around, it could be we could do whatever we want. But when you're working with people's money, you should be really looking into stuff like the compiler versions and which Open Zeppelin version you're using, and is it compatible, and also is it the most up to date? and is the best for your project, right? So
this is why you probably don't want a serious contract built by somebody where they say, hey, for $50, I'll make you a smart contract online.
Yeah,
You want to
exactly.
know who's doing it. Are they vetted? Are they credible?
So anyways, let's get let's just get moving to getting this contract deployed so that we can test this out and then we could see like what would happen. So we can remove this and we can have it as the ERC20 contract, just the vanilla ERC20 contract that we can deploy. And here's the thing, right? With these contracts, anyone can just go in, as you were saying, like the $50, like the guy who comes in and does this for $50 for a token, you can go in and do it and have a token like this. I mean, you just copy paste the same code and just have and just rename these variables and have this token. And here's how easy it is to deploy a smart contract. So for anyone who's like, okay, wow, these people, like, they deployed smart contracts and, this is, crazy that they created, like my friend created a new token, like, they probably worked really hard on this. So here's basically how you could do this, right? If we compile it here, we can see that we got a green check mark. It's all ready to go. So we could just do injected provider MetaMask. So we go here and we just click on MetaMask. And for anyone who wants to do the same thing, it's on remix.ethereum.org. It's an IDE that's on the web. So you can be able to you're just able to create a smart contract like this. And over here, you can have some sort of, beginning supply. I think we said 1, 2, 3, 4, 5, 6, and then I'll put a bunch of zeros at the end, just so we have more supply, maybe less zeros than that. And from here, we should be able to deploy, and I'm deploying to the Polygon testnet. So not to Ethereum testnets, I'm doing it to Polygon. The reason, the difference should be nothing. There's no difference. It's just that Polygon testnets are a lot cheaper. It doesn't cost any money in general, but it's just cheaper to test and deploy on, just to show you guys, how this is going, how this is working. It's faster essentially.
And there are two things here. One, MetaMask is a form of web-based or a web-based wallet, active wallet. And then Polygon is it runs along with Ethereum.
Yes, it is considered a side chain and not a layer 2. So a lot of people would consider Polygon a layer 2. It is actually considered a side chain. Yes, you are correct. So I don't know if you can see on the top right of my screen. Can you see the let me move this over here. Can you see the MetaMask?
Yes, I can. Yep,
okay,
you activate it, and that's integrated with your browser. So this is
right. So it's injected. So it's using an injected provider, and it will call my MetaMask instance. And you can see right here, it takes this much Matic or test Matic to deploy this, and we can confirm. And what happens is now this contract is going to be, creation of my token pending.
Wow.
And this will be actually called on the testnet, and we could go here, Polygon testnet Explorer. So we can just go to Polygon scan, and what we can do is, let me go to my MetaMask here so we can see what the actual account is. So this is the account for the contract interaction. You can see right here. We had a contract interaction, and let me go back to Remix and see. It still says it's pending, so maybe it's not quite there yet, but let's see if we can see it over here. We're on the Mumbai testnet. Yep. And we can go over here and check out if this is going to be completed soon. So no transactions as of yet, but we should be able to see it soon, hopefully. So,
that's right.
As you can see, like a contract deployment takes a little bit. Hopefully this doesn't take too long, but we'll see. And while that's doing that, maybe I should have added more gas into that, but.
Right. And again, gas is basically money on the Ethereum or Ethereum value, or money would be the equivalent. So it's worthy of somebody wanting to do it. It's kind of like say, hey, well, drive me rapidly downtown. And he goes, well, yeah, I'll get to you when I can. And I go, what if I give you $100? Well, we can do it right now,
Right. It's basically, like transaction fees essentially. So,
right. So they estimate what is necessary amount, because just like in a bank, when things go on, someone has to pay the electricity, someone has to do the work, someone has to process it. Now we have the collective community doing it. We need to make it worthy of their energy.
Exactly. Yep. And let me see if this is still pending. So maybe we could do another deploy, see if that will work. I'm going to put my gas all the way up. Let me see where I could actually, okay, right here. And we could do an aggressive gas fee and wait for the gas to update and then confirm this. So this should push it a lot faster, hopefully. We have another creation of my token pending. So we have to make sure okay, there we go. So now it went through immediately after I pushed more gas in. So the guy wanted to mine the block that had the higher gas fee, of course. So
I'll take that job, right?
Yeah, exactly. So that's just like, it's a pretty good example of like what what Martin was just talking about. Yeah. So now we can go through and take a look at where the transaction is on the actual blockchain itself. So we can copy this account name, and we see there's a contract deployment here on November 26th. This has happened. So make sure I'm on the right address. I think this is the right address. So there we go. So 37 seconds ago, we've created a contract, and this is a contract creation for this contract right here, right?
Right. And
so technically now I should have the tokens in my balance on my MetaMask. So let's go take a look at that, and we can go to assets. We have Tmatic here. We can import a token contract address. So we copy this, go back over here. Import. So I think it was CT. So it already auto-loaded CTK as soon as I brought up the contract address and the token decimals. So we can add the custom token, and we can import this token. So we can see that we do have we have 0.00001234 CTK. So maybe I should have added way more zeros to this. So let me go back over here, and then let's do that right now. So let's do CTK. Let's do a CT2 or something like that as this new token symbol.
Yeah.
And let's add a lot more zeros to this. Okay, so this, I think we have 18. So we need 18 places. I think we should have enough. Let me just add a couple more zeros just to be safe. So now let's redeploy here, and let's add some more gas onto this as well. Aggressive, confirm. Okay, so the gas fee changed, so we just confirm again. And we go back over here. We can go back to the wallet address that we had before. This is the address. And let's see if there's going to be any transactions pending after this is deployed. So this block has been mined. And we should see over here in a second, once this is updated, the new contract. So using this contract, we'll interact with it on a UI. So running low on Tmatic. So the way that I can get more Tmatic is, this is the faucet, and a faucet is basically on a testnet. You could go in and paste your wallet address. Any wallet address, you can go to your MetaMask, and you can go to your Mumbai and connect to the Mumbai testnet, and then submit and confirm. And over here, so it says you're requesting the wallet you're requesting has enough to pay for gas. So it's saying that I have enough to pay for gas, so I can't really request anymore. But if you were to request some from a wallet that doesn't have any testmatic, you can go over here and press submit, and you'll be able that testmatic would be coming into your account, and you could actually use this smart contract that we're about to that we've deployed. And you can actually test it out with this, using this testmatic that you can get from this faucet.
And so I want to try an analogy to testmatic, and it's kind of like saying I need some more monopoly money.
Yeah, exactly. Yep.
It's not real money, but it's monopoly money to play the game. and you
Right.
go, could I get some more Monopoly money? We're playing a game, we're having more people, and we need more. And then there's a source to go to. And it's all done in simulation, just as though it's on the real thing. So you can, and that's amazing. So you can test it out.
Yep, exactly. Yeah. So that's why I'm telling people to go and interact with this. I would never tell people to interact with it if it was dealing with real money. It's all fake. You just go on the testnet and make sure you're on the Mumbai testnet. If you know what you're doing, try this. Try not to do anything with real funds or whatever. So so from here you can see that there's a contract creation. This is the contract address, and we can copy this and then add this into our MetaMask. I'm gonna have to delete this other so CTK, and then we can import another one here, and this is another CTK. So hopefully this is the right one. Okay, there we go. So import tokens. So we have this much CTK. So we have a lot of CTK to and this is Christmas token. Yeah. So
our Christmas tokens, we've got it. Yep. We're ready for the holiday.
Yep. Exactly. So we're going to hide the other.
We could have made it holiday tokens, folks, but we just picked Christmas.
Just anything, right? So
just for education.
Yep. So right here, we have this many tokens, and there's a transfer event that we could do. So I can actually, send here. I can send to another address. Let me see if I can go to a different account here. So I have a couple of testnet accounts, so that you can see over here. You transfer between my accounts. I can transfer to account 1. So this is account 3 that we're on right now. But we can transfer this to account 1.
Which would be kind of like you sending it to my wallet,
Yes, exactly. So let's go. I'm going to go back to this. Okay, so send, transfer between my accounts. I could send, say, like 1,000 CTK to account 1, right?
Yeah.
And this is just gonna, confirm. I probably should have add more gas, because honestly, on the testnet. So the reason why you always add more, I should speed this up. The reason why you add more gas on the testnet is because no one cares about their money on the testnet. So people just go full gas. So to compete with other people trying to get their transactions through on the testnet, you want to push more gas. So as you see, we have a send here for negative 1,000 CTK. And if I go to my account 1 now, I should go to my assets. I haven't imported the contract address, so let's do that. And you can see there I have 1,000 CTK on this account. So so there's a transfer event, and what the send is doing is essentially it's calling this transfer event that we were talking about from the Open Zeppelin contracts, right? Yeah. We were, it's just calling that transfer event, and we can actually do that on any UI ourselves. Like we can have it so we can interact with it. We can call whatever function we want. We can create a function and call it and do do anything that we basically want to do. So say now if I let's create a variable, right? And we can create like a uint 256, and we can have that as like random number or something, right? And then we can declare that as like 2, 3, 4, 5 or something like that. And right there, now I'm not going to deploy it onto the testnet, but we deploy it to the VM London just as a testing thing. You could see over here all the functions that this comes with, right?
I see.
So this is the transfer function that we just called using our MetaMask wallet.
Right.
And we can go over here and try to look for, what did we just name this? Random number. Here it is.
There we are.
So I had to actually refresh the deployed contracts. So over here, random number, if we click on this, it gives us back 2, 3, 4, 5, right?
Cool.
So if I were to go onto any website, any kind of token website and call this, I would be able to see this number. I would be able to, all I have to do is call random number, and then this would give me back 2, 3, 4, 5. So from here, so you could see like how this can be, how this can be used in a smart contract, where you can view you can view any variable on a smart contract. You can view this actual code. You can't, there's some ways you could private data, but really you can, the power of it is essentially everyone can be able to see what the data is on the smart contract, right? Any public variable you declare, anyone's able to view it on their sites. And I'll show you actually a website that I was using and that we were going to call actually the smart contracts from. This is like my sandbox. And you could enter in an input, and over here, I create like a test, like bunch of inputs or whatever, and then a big button. So over here, if we were to attach our smart contracts to this, we can transfer, 1,000 CTK to someone, right? Just to a wallet. If I were to enter in the receiver address.
And if it's useful, I went ahead and signed into my MetaMask if we want to play with something.
Yeah, sure. That's actually a good idea. So if you actually go over here into this, let me send this actually in the chat here.
Yeah. And I'll bring up.
So let me actually send this link in the chat. So you can go to that site there, and it will prompt you to switch networks to the Mumbai testnet and add it to your MetaMask.
Cool.
So that way it automatically adds it to your MetaMask. And then if you go to the Polygon faucet, and we can edit all this stuff out, right? Like all this part out.
Yeah, absolutely. So do you mind if I grab the Zoom just to show what I'm doing for people so they'll see it too?
Yeah, sure. Yeah.
I'll grab the screen. That's the one. Which one? Here, we'll walk through it together. So let me stop and I'll share my screen.
Yep.
Because I think this is so important for people to see and understand. So I'm here and I've got MetaMask active. Okay. And right, we don't need that education facts there. Okay. And
okay, so you're on Polygon. Go to your MetaMask. Are you on Polygon mainnet, or does it say the Mumbai testnet?
Let me just hang on. There we go. Okay.
Okay, so go to home and in the website, go to the home page.
Will do. Yeah.
There you go. Switch network.
Ah, yes, of course. Switch networks. There we go.
Yep, and there you'll be able to see the pop-up that will let you automatically add the Mumbai testnet to.
Yeah, and it says, "Hey, do you want to let us connect? This is where you want to know what you're doing."
Right.
Approve?
You just approve on here. And on other sites, you do have to read. MetaMask has done a good job of like translating a lot of what the code is doing to like words on the screen. So it'll be like, okay, this is switching. This function is like switching the network. So you need to know, if MetaMask is telling you like this is switching the network, or you are using some gas, or you're paying some money, this is a transaction. You need to be able to tell, the differences between all of these, right? So making sure you understand that in the MetaMask environment is important.
Yeah. So ready for me to switch?
Yeah. So go ahead and switch
networks.
And then there we go. And once you see this, now you've switched networks, you're on the main page. Okay.
Right.
So from here, you don't really have to connect wallet yet, but you can go to the second link, and that second link will now get you, will copy your contract or copy your wallet address from your MetaMask from the Mumbai testnet. So right there, account one. So copy, you see there's
that right here. Right.
Copy the clipboard address. And then go to the second link that I gave you, and that's the faucet. So the faucet, actually what it does is it just gives you monopoly money, right? Like, as you're saying, it's like the bank in a monopoly. You just kind of go there and they give you a matic token that will help you traverse the testnet.
Right. And so this is my receiving address in MetaMask in this system.
Yep.
That I'm pasting.
Yep. Now you could paste it.
Oh, wow. It says, "Hey, do you want me to do it?" Yeah, there it is.
Yep. And then you could press
for receiving. And
Yep. And you could just press submit, and it should let you, unless if there's like, it usually takes a little bit, but it should just let you just send you tokens, or it should submit a request to send you tokens.
And it popped up. Are you seeing the pop-up?
Yep. I'm seeing the pop-up.
Okay, good. And then I'll click confirm.
Yep. There we go. And
submitted.
So your tokens will be transferred to you within 1 to 2 minutes. So we're just waiting out that, like, it's usually less time, but 1 to 2 minutes is what they kind of give you as a, as just a precaution or precautionary amount. So while you're doing that, I'm going to be trying to find this ABI that I am supposed to find, but I have no idea why it's not showing me where the ABI is.
And while you're doing that, I'll just say, if someone's not as familiar, MetaMask is kind of one of the standards for interacting with, smart contracts online and everything else. And you can transfer stuff from a hardware wallet into MetaMask. And
Right.
And my friend that has the Localist DAO that we work with MetaMask, and he sent me some tokens so that I could interface and be on his DAO. So this is a very important one for people who want to play with interaction. Just pay attention, and if you're a newbie, don't put a lot of money in here while you're working with it, right? And know where you're connecting.
Right. Testnet's a really great place to like learn how to use Web3 and like actually interact with a bunch of stuff without having to burn through a lot of your cash. Because normally, if you're going to be doing all these transactions on a mainnet, you're going to be paying a lot of money for transaction fees and stuff like that. This way, you can kind of get used to interacting with smart contracts and whatnot. And actually, the website that is in that link is one of my GitHub projects, and there you can use the Matic testnet tokens to mint an NFT. You can learn how to view your NFT and kind of walks you through the NFT minting process of a minting site. And it will also, as we're going to connect the smart contract right now, you can actually transfer this token to someone, or if you have it in your wallet, which I don't think any of you will, because there's no way to get it other than the way that we're doing it. So that's essentially what we're trying to go through now is kind of walk through that website. So if you go to your MetaMask, check if you have your testnet tokens. There you go. Yeah. 0.2. So you got your 0.2 T-Matic that I gave you. And this is what they think is enough for gas. Although I kind of disagree at this point, because everyone's using way more gas than they should be using. So their kind of calculations of like how much gas you need to use. And you can always like create, if it doesn't let you add more, you can always just create another account. Like really, it's like a free account on testnet. So, and then just add in more gas. So it's not too big of a deal there. So one thing that I wanted to show you is actually you can go through and you can test out a smart contract on the org portal itself. So if you go back to the website using that 0.2 Matic, we can actually test a smart contract that's on one of the smart contracts that I deployed that is an NFT smart contract, and you could see it. So if you go to there's a right and a left button right next to Orcs v2. If you go to the right and go to Orcs v3, there we go. Now Orcs v3, you could first connect your wallet on the top right. No. Like you see this.
Excuse me. You're right. I got it. Connect wallet. We got to initiate from here.
Yep. So if you connect your wallet and we don't see any of this stuff that's happening right now, because I think this is a secured part. And MetaMask is actually pretty smart. It can hide itself from screen shares, which I really like. I think that's a smart idea.
Nice.
So whenever you're connected with your wallet, you can mint a free orc on the Mumbai testnet. So this is all on the Mumbai testnet, nothing to do with like mainnet or anything like that. That's it's really nice to be able to just have access to like free NFTs. And I was telling my friends, I was sending them like some NFTs on like that I created kind of. So and these are all testnet NFTs, and they're all like, wow, this is like incredible. And I'm like, yeah, this has no monetary value whatsoever.
Right.
This is just all fake. Like
these are fake monopoly money or tokens you're getting. So
exactly.
I just want to see on my MetaMask, it says account 1 with 0.2 T-Matic, and then it has next. So you want me to go ahead and hit next?
Yeah. So just follow through with that. Nothing on that should be any. Yeah. When you're going through like a website that you are not familiar with at all, I would recommend like reading those dialogues a lot more. this one, this site, and especially like, so right now you're connected to Mumbai testnet, right, on your MetaMask.
Yep, that's
It
right.
will never let you call an Ethereum smart contract with when you're connected to the Mumbai testnet. It will always ask you. So if you're looking at, if there's a malicious site that's wanting your real funds, it would ask you to switch over to the Ethereum net, because that's the only way injected providers can access data, right?
Yep.
So you would need to switch over to your Ethereum mainnet. This is why if you're looking at my MetaMask, I'm always connected to Mumbai testnet, because Mumbai testnet, I know that if there's any contract that's called, if it's something that's supposed to be, it's supposed to be on a mainnet, it will make me, it'll call to make me switch over to, Ethereum mainnet or something like that, so that I will have that extra bit of confirmation, be like, okay, so what this is doing. And if I ever, it also gives me a better look into how that website is designed, because it's something, if the website is not making you switch over to another, isn't making you switch over to mainnet, then it basically is a cheaper website, because you normally want like good user experience, right? So like if you went onto this website, you saw that like you saw that it made you switch to the network, and then it made you switch to this, like it has those user experience kind of implementations already within it, right? So if I'm going to a site that I'm buying an NFT for, and if I'm an investor in that NFT or a token or whatever, I want to make sure that website has good quality like user experience, especially it's using all the MetaMask features like switch network, switch to this account or something like that. Like, you don't have enough funds on this account, so we're not going to call it smart contract or something, right? So yeah. So now that are you connected with your?
Now it says, I just want to say, it says it will see address, account balance, activity, and suggested transactions.
Yes.
And because I know it's the test, I'm okay to say connect. Okay.
Yes,
now it's doing a little connecting thing, and now it's connected, and we know it because of the is the right word to call it the hash in the upper right hand corner.
You're basically, that's the address. So that's
the address.
Yes. So that's your
address
wallet
in
address.
The upper right hand corner. Yeah, the wallet address. Yeah.
And so now you can go ahead and click the big button in the middle. It says Mint Orc.
Oh, right. Bang, I'm clicking on it now, and it's opening up my mask again.
So this will mint you an orc theoretically, unless so the way that I created this smart contract like a few months ago. And so I uploaded the NFTs to IPFS testnet.
Right.
Well, not IPFS testnet, IPFS, and then it's on the OpenSea testnet. So, so IPFS likes to kick things off of IPFS, because if you don't do something called like IPFS pinning, and IPFS, for those of you who don't know, is Interplanetary File System. It's basically a database it's a decentralized database where a lot of these NFTs reside. So the data in pictures is not allowed to be stored on the blockchain itself directly, because it's too big.
Right.
The way that, Web3 has solved this is they've broken images up into smaller chunks, and they've uploaded it into a decentralized protocol. And this decentralized protocol is called IPFS. And you can upload a bunch of these NFTs to IPFS, and it's always available there if you've pinned it. If it's like a testing thing, you usually don't pin it, and you don't want to like use up IPFS resources. And you also have to pay a little bit of money if you want to pin it. So for this was a test. These are all testnet NFTs test. This is this whole portal is all testing. Essentially, it's my testing environment for a lot of my contracts. So this is, and I didn't want to spend money on that, right? So so basically, this is how I got through it, and hopefully it works. So
now what I want to say, it says right now in the upper right hand corners, it says new address detected. Click here to add to your address book. Then it has the link and an address, details, and it says estimated gas, and it looks like we have enough. And
you want to switch the gas to aggressive.
Okay.
I think you saw how I did it on my thing. It was like this market. It was like where it says market, and then you would click on that, and then aggressive which is the highest, and then submit there.
Gas fee, amount fee. Let me see. Did you hit? Let me just see what it is. Did you hit an edit under details or data? Let's see.
I mean, it said, I think it said market. That's what it had underneath.
Let me just check here.
MetaMask changes its UI a lot, just like Remix, which is
right. And it. Oh yeah, hi. I got it now. It's going to say hi now because its network is busy, is what it's telling me. Okay, great. So I'm going to hit hi and then save. Likely 15 seconds now. Now I'm scrolling down to confirm. So that'll be my next one to get here, and click confirm, and it's on way.
So now technically you should, if you're just sitting on the screen, you should be able to see when the transaction is finished. You should be able to see like a pop-up that appears. And this is also another thing I was testing out. It's events on smart contracts. So there's a new thing called event. They're not really new. They're just event emitters that are kind of not used as widely as they should be in smart contracts, in my opinion, although it uses a little bit more gas. So what I did to this smart contract, Orcs v3, is I added an event emitter. So when it's finished with the mint, it should pop up with a pop-up screen showing the NFT picture of what exactly the NFT looks like. And it should, if it's still on IPFS, which I still don't even know if it is or not, but when it pops up, it should have like a big screen or whatever. And you could see on your MetaMask, you can see, it says contract interaction failed. You see right there?
Oh, yes.
So let's look at why. So if you click on that, you can see why. You can probably see why. If you go to, can you go on view on Block Explorer?
Yeah. Let's go Block Explorer. And are you following me? Or
yep, I could see it. So right there. So contract execution out of gas. So yeah, probably needed a higher amount of gas there. And that's so yeah, you could just go back and then do another one of them, and then you could try to add the most gas in there. So this is the other thing about like when I was doing this testing is like gas optimization is something that's really important. And with this event emitter, I was noticing in V4 I actually updated this, but I haven't ever updated V4 on this on the org portal. V4, it was a gas optimized version of this, but this is like, as I was saying, the event emitter was causing it to have more gas usage, where a smart contract shouldn't have that much gas usage normally. I mean, some smart contracts do. A lot of production smart contracts will have a smart contract that not only calls a function on it, it calls a function on another smart contract. So it'll call like more, one smart contract will call another one, and then another, that smart contract could call another one, and you got to pay gas for all three of those calls. And like, it's crazy amount of gas that you can possibly end up using. But yeah, normally for a mint, usually this is on the higher end for gas prices.
So should I click mint again?
Yeah. So once you mint again,
opened up. An address, new address detected. Click here to add your new address to address book. We don't want to do that.
Yeah, we don't need to do that.
Likely 30 seconds if I just run it as is. Maximum amount is 0.00064, and I should have enough money, or meta testnet, thank you.
Testnet-matic, yep.
Testnet-matic coins. So should I want me to just go ahead and hit confirm now?
Yep. So yeah, that it has nothing to do with how much you have. It's just more like it's more like what the gas price is at the moment for the network, and what it's calculating it to be. If it runs out of gas, then it sometimes would run out of gas.
Okay, now we're pending. There we go, pending. You can see.
Yep.
And let's.
It worked. Okay,
it worked.
So as you can see right here,
Yay!
yeah, there you go.
Here we go. Oh, that's fun.
And
so
the
NFT.
And that's my artwork. It's it's my original artwork.
Guys,
there.
I think you should keep stay in Web 3.0 and programming.
I completely agree with you. Honestly, I think that's like when I was and you can actually get, so there's like. You can get a blue orc, a yellow orc, a red orc, or a green orc. So Yeah, so I was actually like, I was joking around with my friends about this too, and we were just all laughing about it too. Yeah, it's a pretty cool feature, I think, event emitting and stuff like that, especially if you can get it down to like a really gas efficient stage. It's pretty nice. So if you X out of this, and then if you go to the top right, click on your wallet address, and you can see right now you have one orc. You see on the orc icon?
Yes, I do.
Yeah, so now you have one orc, and it tells you how many orcs you have. And now if you go to your wallet address,
go to the wallet address.
No, on the top right of the website, that wallet address.
Oh,
it should load up your.
I got you. Absolutely.
So and there
we go. So in our system, there's my one blue orc.
Yep, and that's just like you have there's orcs v2, orcs v1, orcs v2, and stuff like that.
This reminds me of OpenSea, where you might be able to look.
Yeah, if you actually click on the blue orc right there, and it should just send you to OpenSea where the blue orc is located. That's your blue orc right there. That's like, there you go, and then that's your that's the new NFT you just created, and you can see like the whole collection, like how many people have minted it and like whatnot and stuff like that. It's pretty cool. Like I and that's essentially like what we're doing there is we're calling a bunch of functions on the smart contract, right? And you can see a bunch of the other ones, right? Like there's the red orc, the green orcs.
You could get the whole family if you want to.
Yeah, exactly.
Well, excellent. So we could stop and let you take it from there.
Yeah, so I hope I hope you enjoyed like the kind of demonstration of kind of how a minting site would work and how you can interact with a testnet, because I think that's something important to have, right? So we can
you can share again if you like.
Yeah, we can take a look at, actually, instead of me going in and adding new code for the
go ahead, share the screen again. Excellent.
So instead of me going in and like trying to figure out where this ABI was on this, because I don't know, they changed the UI for sure since I last used Remix. Yeah. Because it was somewhere over here, and I don't remember where they put the ABI. But if I was able to access that ABI, I would be able to, connect it to the website and then have it usable there. But I'll go to the smart contract that you just interacted with, and this way people will be able to see, like, we used the demo and now we're able to see what's behind that demo, right? Right. And I think this is a good way to do that. So we can go back over here, we go to our workspaces and go to the default workspace, go to contracts, and we can go to orcs v3. So this is orcs v3. This is the contract that we were just interacting with.
Oh, cool.
So this is how this
actual contract.
Yes. So when you call the mint orc, and this is what I'm talking about when I'm talking about the event emitter, right? Right. So, over here, you can see this is a ERC 721, not an ERC 20, ERC 721. So this is an NFT project, and you can see the max supply is set at 10,000 for this. And basically what it's doing is when we called this is a function that we used. Right. So we called this function. We also called, without you probably knowing it, we called token URI. We called token URI, which is basically what it's doing is it's getting the image. So it's just for you to look at the image. I can maybe actually deploy this on not on the testnet again, but on the Remix London here. We can go over here, and when we deploy this, you can see where's the mint orc. So if we go to the mint orc and we use this address over here, right? As you can see, we can mint the orc, and it should mint. Okay, so it minted immediately, and you can see the total supply now is 1. There's one person that owns one of these orcs. I just created this new contract, right? So if I go to my token IDs, and if I go to, I think token ID 0 would be the first one. So right here, yeah. So token ID 0, which is the first token ID, we just created this one, will point to this. And this is the token URI. And what it's doing is it's this URL, if I were to put it into, the IPFS gateway, which I don't have the URL for at the moment, but if I did, and if I were to add this on to it and looked up the URL, it would show up with that. It would show up with that image, and that's how I'm able to find these images and post it on the website. So what it's doing is it's basically calling this token URI right here. And it's just getting, our token URI with the token ID that we passed in. So not going into detail here, I just wanted to show everyone that this is how that mint orc function was being called, right? We have an event that's mint finished, and this mint finished is going to emit once all this has happened. Like once we got the token, once we've created the token, we've got the random number for which token we're getting. So we're, as you're seeing, we have the token from 1, 2, 3, 4, right? We've had the red orc, the blue orc, the yellow orc, and I don't know which other color, green orc. So this is going to determine which one you get. This random number.
So I wasn't able to get one. I'm going to get one in the collection, and then the next time I might get another, but I might get 2 reds. It's sort of like when you go to a fast food place and they got the kids' toys. You may have the same one each time.
Exactly. And for those who are, into Solidity development, you might notice that this is a vulnerability here, right? So this is a get random number. If you've looked at, I think I scrolled down far enough to go to this get random number. The way that I'm using get random number is not the way that you should be using getting a random number, because you should be actually using Chainlink or some sort of Oracle to get a random number, and that API will get you a random number. Reason why I didn't use Chainlink here is because I'm doing a test. So I just wanted any random number, just as long as it's 1 through 4. So the reason why this is a vulnerability to everyone else is because it's using block timestamp, and block timestamp is a bad thing to use random numbers off of. Especially the reason why being because miners can actually manipulate the block timestamp somewhat. So if this was a super important contract and you really needed random numbers, and you needed random numbers for something super important, I'd say, you should not be using block timestamp. You should be using like a Chainlink Oracle API. For this, it's like, okay, if a miner decides that they want to manipulate the random number, the block timestamp to get the random number to generate a yellow orc, like they can generate a yellow orc or a green orc if they were to try to act maliciously. It would be kind of difficult for them to do, but it's possible to do, which is why this is considered a vulnerability. I just wanted to point that out, just so people looking at this.
They look at it and go, why did you do that?
So I just wanted people to know that this is definitely very much a test contract. So, but everything else is like, it's pretty nice in terms of gas efficiency. This is not the fully updated ORC v4, but this is the ORC v3. But the emitter is there, and this is what it's doing. It's basically minting an orc, and it gives you an orc that it will mint on chain, and this will go into your per person. It will show up in their mappings, right? Their individual mappings on their accounts. So just wanted to go through that. I hope everyone understood sort of when we went from how we can go from creating a Polygon Matic, a Mumbai testnet account, to adding new funds into that, to then calling a smart contract, to then now seeing how a smart contract is working on the back end. How we're using the mint orc function. It's just a bunch of functions on the back end, and you could do whatever you want. Like if I wanted to call my get random number function, I think I should be able to do that if I'm where is the get random number? It's a public view.
I just want to add is each one of these compilers are evolving each time. So if you've played with this a month ago and coming back to it, it's gonna you have to see the upgrades and work with it, right. So Solidity doesn't just because. So yeah, as you were saying, like where I've indicated a compiler version right here, right on my smart contract, and I have to have this compiler version there. And this caret here basically means that like any of these versions and above is fine for this contract, right?
But normally if you were to delete this, this is going to give me an error because it won't let me. But so this means that I should have to give you. I'm only using this 0.8.4, only use this compiler. And if I go over here, if I go to my compiler version, you see I'm at 0.8.7. I would need to bring this back all the way to 0.8.4, and then this error would go away. So this is saying, okay, if you're going to use any other compiler above this, then this will fail. So if there was an update, like you were saying, like, okay, so if there's an update to where that zero reset, the overflow problem was, where if you had a higher data point than what the data allotment would be, and they suddenly updated that to not work, then your smart contract wouldn't necessarily be screwed, hopefully, like, thankfully. So instead, you could just kind of say, okay, so I only want this compiler version. And if I were to, add this caret back, then, then I want any compiler version above 0.8.4. 0.8.4 is going to be my, my lowest level compiler version. So normally, like for a production level smart contract, you would kind of be specifying more precisely what your compiler versions would be, so that, and you could do it like a range of compiler versions, so that you wouldn't really fail. The smart contract would never really fail in terms of like if there's a compiler mismatch on the EVMs. When they are having these compiler versions, they'll have all these different compiler versions on them, so that they will be able to process any smart contract request for each different smart contract, even though if it's on like 1.0 at that point, or like 0.9, 0.5 or something like that, then it would be able to process those ones plus the ones that are older on like 0.8, 0.4, like stuff like that. But I hope that makes sense. Like where your question was, will it be affected so much? It won't be affected too much if you just use your proper Solidity declarations right here. But yes, it is important to know that if there is a Solidity update and there's a compiler update and you're creating a new smart contract, what you should be able to learn from like what is new in the smart contract compiler and what can be changed in your smart contract to be updated. Because when a compiler update happens, a Zeppelin update could happen. There could be a 5.x soon, and that would be like, okay, so I'm using a 4.x Zeppelin, and I'm now on a compiler version that's 0.8.0 or something like that. That's going to be a mismatch if it's like a 5.x or something like that, where you would have different features on a compiler versus what you're using on Zeppelin. Yep. So making sure you're keeping your eyes peeled for that. That's a little bit more on that, like, that's a little bit more for the developers out there. But for the people who are just the general users, just know that any of these functions here, these function names are what you're basically calling on your when you're naming smart contracts. And on MetaMask, you should be able to see actually the function name that you're calling on MetaMask. Right. So it'll say like, you're calling mint org, and even on the blockchain explorer itself, it should say what. Let's see if we can find a smart contract interaction, right? So so this is the address for this, and we could do a contract interaction somewhere here. So it might. So we're calling orcs v3, and we're actually transferring. I think we're just transferring. We're just transferring here. So let's see what kind of. See what kind of things we could find out here. Okay, well, maybe it might be easier to look at like actual other smart contracts on the. Okay, so right here, you can see on the method right here, the methods that we're using.
No, I'm seeing OpenSea. There we go. Yeah, back there. Okay.
Okay. So on these are like Matic transactions, right? And these are transfer methods. So this is what they're calling. And hopefully I could find like one that's not a transfer method, and that's something that's like. Something that would be, maybe I could view contract creations. No, there's not. So this is within the I think this is the last block transacted. Yeah, I can only see transfer. But if it was a mint orc function, right? Yep. It would say mint orc here, like in the methods. So basically, that's what I'm getting at is. over here, when you're calling these, functions, you should be able to see them on the Blockchain Explorer. You should also be able to see it on the MetaMask. And also, and if you don't see what function name it is, I would not really interact with the smart contract unless you can, because sometimes there's some smart contracts that aren't really verified. And I think, let me see, the smart contracts that I'm using, these orcs, they aren't truly verified because they're on a test net. So I'm saying if you're on a main net, you should be looking for if they're verified or not. And let me go to this really quick. So as I was saying, this get random number here, right here, you can call this get random number. This get random number is never really called on the front end. You're never really able to see it, but it's being called internally by another function here. But if I were to say get random number here, I can call this and it would get me just a random number, like a uint 256. It's a random. And if I keep calling it, it'll keep giving me
different ones.
Different ones. So this is was what I'm saying. Like, you can call any function that's available to be called. If it's public, it'll be able to be called. One other thing to note is that if it's a public, if it's a viewable, and if it's nothing that has to do with the transaction, it's free. So as you can see, this get random number, it's free for me to call this. And if you're wondering why there's no gas fees for this, it's because I'm just viewing. It's a read-only function. I can only view this.
Gotcha.
Yep. So if I were to
not doing anything.
Yeah. If I were to go to Mint.org is I have to enter an address, and this is going to be computing something. This is going to be, it's going to be doing something. So as you can see, these orange ones like that Remix has good UI here for these orange ones are stuff that's going to be doing something that's going to cost gas. These ones are all views. So I can see, I can see the owner of a token ID. So if I go to token ID 0, I can see the owner of that token, and it's free. And this is a good thing. I mean, this is really nice because it allows for websites like, these ones to exist, where if you can connect your wallet and you can go to this, I can view who has what, I have a green orc, a blue orc, or 3 blue orcs and a green orc, right? So I can view these orcs essentially, right? So, and that's, I'm just calling that basically over and over again. And these, when I'm calling these, I'm just saying view token URI, and then I'm viewing the orc of the owner. So owner of, and I'm just doing like a whole mapping on the UI. So that's something that's something that's a little bit more in depth, but this is basically essentially what's happening. It should be quite clear what's happening on the smart contract side and what we're doing to get to this point, and how you can interact with smart contracts and how you can interact with more safely, right?
Yeah, this is excellent. It's a beginning piece. This was so exciting to see an overview, and I just want to say, a lot of people, this might be overwhelming. It's fine. It's more like, so you could see this is real coding. You want to have this thought through carefully. And this is what's going on when someone says smart contracts, because, our world thinks of something written down, not as just lines of code.
Yep. And I hope everyone when we went through that, I hope everyone understood what a smart contract really looks like now. And they understood that it's just a bunch of functions. It's a bunch of code that's on a screen, and what the code and the functions look like in the raw text form, where, you're always talking about, oh, I'm sending you some ETH, or I'm sending you this token. How does it know that I'm sending you this token? What is the token versus, Ethereum, that kind of stuff. So if you're able to take, once you're going through this video, you're able to see this, and I hope, you guys understand. If you guys have any questions, you could obviously, ask. So yeah,
post them below as well. The big thing is, we wanted to take the next level dive on what a smart contract is, and that this is something important. And it's also important to not just go on the cheap, but have someone professional like you build it, verify, or even have a secondary person like yourself that's brought in to verify a contract and go, yep, that looks solid. There's no and to also demonstrate that this can all be done on a test platform with what I call monopoly money, to try to poke holes in it and see where it might fail.
Yep. And if you're ever like, if you're ever trying to invest in a project, you want to make sure that, yes, there is an audited version of the contract. You wanted to make sure that, someone's looked at it, and reputable people have been, working on it, because, there's a lot of stuff that can go wrong. If you can, there's been recent crypto controversies, and, we all have seen them, and it's a new world. So, and people don't understand it as much as they should. And because of that, then they get caught out. And these people who are getting caught out are now, these people who are benefiting from these people getting caught out. And it's pretty sad to see. So hopefully this will bring a better view of like how Web3 is working internally, and just to show people, okay, this is what I should be looking out for. If I'm clicking on MetaMask and I see a function name, this is what the function name would look like. And you could obviously go to the Blockchain Explorer now, and you could see what, that transaction's doing, and exactly what the code looks like. So, yeah.
Yeah. Integrity through transparency. This is the best real world example of it. Well, this was excellent. I'll put the links below so people can connect you on LinkedIn. And thanks again. More coming, folks. Really exciting.